This is chapter 1. The subject is logarithms. We will solve exercises of the chapter. Now in exercise 1, calculate the logarithms. On A, we have logarithm 1/3 to base 1/3. So as we know, the fundamental identity of logarithms saying that the logarithm equals 1 if the two values a and b are equal. In this case, we take this idea from the property and apply it here, so the final answer is just 1. On B, logarithm 1/8 base 2. As we know that 8 is 2 power 3, when we switch 1 over, the value is going to be 2 power negative 3. And when we use the property of x power m, means that m will be multiplied by the logarithm. So then, the value of logarithm 2 base 2 is equal 1. So then only negative 3 will remain multiplied by the 1, and the result is negative 3. On C we have ln e, and we know that ln is a special case of logarithm with base e. So now both values are equal. So again, with the main property of the fundamental is the result give 1. And here is the property. On D, logarithm 1 for any base, we know that this is a property of logarithms saying that 1 for any base gives 0. And here is the result. E, logarithm 2 to base square root 2. So then, I need to rewrite 2 in the form of square root 2. And I know that square root 2 squared is 2. Now, those two values are equal, and 2 can be multiplied by the logarithm, and then it is going to be 2 times 1 and equals 2. And here are the properties that we used for the exercise. Also, logarithm 1000 under the 5th root. You know that if there is no base written, it means that the value of the base is 10. So here is 10. And here is the 1000 written as 10 power 3, all raised to power 1 over 5. This is the formula of the 5th root. So now, 3 will be multiplied by 1 over 5. It is a 3 over 5. And now, by the property of power m, which will be multiplied by the logarithm, so logarithm 10 base 10 is 1. And the result is just 3 over 5 multiplied by 1, and it is 3 over 5. For the same exercise 1, we will calculate. Now we have in G logarithm 1. And we know that logarithm 1 for any base, the result is 0. So the answer is 0. Now if we have in H logarithm ln e. So first, we must solve the inner value, ln e. And as we know that ln e means the base is e, so both are equal here. So then the value of ln e is 1. Then logarithm ln e is logarithm 1, and logarithm 1 for any base is 0. Now, in I, we have ln cubic root of e, means that e is raised to power 1 over 3. And just we know that ln e, so the base is e. So 1/3 will be multiplied by the ln, and this is equal 1. So the answer is 1 over 3. In J, we have logarithm. And inside the logarithm, we have 9 ln e cubic. So we must solve the inner value. And as we know, ln e, if we remove the 3, this is going to equal 1. So logarithm 3 for 9 multiplied by 3 ln e, thus the power of e will be multiplied by the logarithm using this property. M was a power and now it is multiplied. So 9 times 3 is 27 and ln e equals 1. Now we have logarithm 27 to base 3. Just rewrite 27 in the form of 3. This is a 3 power 3. This 3 will be multiplied by the logarithm, and we will have logarithm 3 to base 3. Those two values are equal, so the value of the logarithm is 1, and the 3 times 1 equals 3. Here are the properties that we used. Now in K, we have ln logarithm. No written base means 10, 10 power e. So this e is a power. This will be multiplied by the logarithm. This is the logarithm. We wrote the base to compare here. And the e is going to be multiplied by the logarithm. So here the value is 1. Then it is e times 1 equal e. So ln e also equals 1. The last one, L, this is ln logarithm 10. Again, the value of the base is 10. So here it is. 10 and 10 are equal. Thus the logarithm inner value is 1. And ln 1, just like any other logarithm, when the value 1 for any base, the result is 0.